Hello everyone. So in today's lecture we are going to study about queue, that is one of the linear data structure. Previously we have studied the stack data structure, that is also one of the linear data structure. Now today we are going to start with the queue. So as you know, like what is queue first of all? So queue is nothing but it's an ordered group of homogeneous items of elements. As you can see in the picture that usually we at any like payment counter or at the ticket counter we usually stand in a queue, right? So whatever like person is first one, he is the first one to be taken out, right? So the same thing, queue is having two ends, right? So first one, that is elements are added at the one end, that is called as a rear end, and the second end, that is our elements are removed from that end, that other end is known as front end. So the element that is added first, that is the first one to be removed. So ultimately it will follow the FIFO structure, that is first in, first out. Now there are various types of queue. That is a simple queue, simple that means linear queue, then circular queue, double-ended queue and priority queue. So in today's lecture we are going to cover this linear queue. So first of all, what is linear queue? So it's a simple queue where we define like a simple operation we can have where insertion can be done at the one end, that is a rear end, and the deletion can be done at the another end, right? So we can have like, suppose for implementing queue right now we are using an array, right? So suppose we are having this array that we are considering as a queue. This is our front end, right? And this would be considered at rear end. Right. So if I am having some data, suppose I am having initially my front that would be equal to -1 and rear is equal to -1, that is our initial situation, right. So initially we have like this. Then if we add the very first, like this is index like 0, 1, 2, 3, 4 and 5, that means I am having the queue of size 6, right. So n minus 1, that's a 6 minus 1, that's a 5, right. So first element, if we insert the very first element, at that time my front and rear both will point to the same pointer, that is 0. So that means I am having some data over here, right. Now if we want to add one more data, yes, that is possible. We just need to increment this rear, right. So we have 2 over here. Now this rear is not pointing over here, rear is pointing to the first one, right. If I add one more, then here, and my rear will point over here, right. So this is a simple scenario that this and only one add we can add elements, that end is called as rear end. Now if we want to delete any particular element, right, so that deletion is performed from the another end, not the same end, but the another end. So here the another end is front end. So if we want to delete something, we cannot delete this 5, no, that's not possible, right. If we want to delete this 3 would be deleted first of all, and my front will be incremented. So after that deletion, this front will not point over here, front will point over here, right. So this is a very simple situation in a linear queue. So in a linear queue, what we do, we can also consider it as a simple queue, right. So what we do, there are two ends only, one that is a front end and another that is a rear end. Insertion can be performed from the rear end and deletion can be performed from the front end, right. So we'll see the algorithm. So first we have this Enqueue. Now what is Enqueue? Enqueue is nothing but insertion operation in a queue, right, and usually insertion is done with the rear end. Right. So we are going to insert the data from that rear end, but before that we need to check for the overflow. Now why there is a need for checking the overflow? Because here we are considering array, right. So we are taking array to implement queue. We can also take linked list to implement queue. Linked lists use dynamic memory allocation, so there is no need to check for overflow, but right now we are considering array that have static memory allocation. So in that static memory allocation, we need to check for the overflow. So the first step is checking for the overflow. Now how can we check for the overflow? So the simple condition is rear is equal to n minus 1. Simple, as you can see over here, my size is 6. Let me have it over here. That suppose this is my queue with like 0, 1, 2, 3 and 4 with size 5, right. So, in only one situation I can say that my queue is full. So, that means like suppose I am having all the elements filled up, right. So, my front is pointing over here and my rear is pointing over here, right. So, what you can see the relation between the rear and size, that is I am having size 5. So, rear should point to the size minus 1, right. So, if my rear is pointing to size minus 1, rear is equal to size minus 1, that is the situation we have, right. So, that is over here that rear is equal to n minus 1. Here what is n? N is size of your queue, right. Then simply print queue is full and then you can return from here, right. Then the second situation, that means initial condition, simply what we do that if we have this and 0, 1, 2, 3 and 4, right, and we have some data, right, this is my front and this is my rear, right. So, to insert any of the data I can insert at this position only, and for that we simply do r is equal to r plus 1, that is increment my rear, right. But for the very first scenario when my queue is empty, so this is 0, 1, 2, 3 and we have one more 4, right. So, initial condition my front is pointing to minus 1 and rear is pointing to minus 1, that means we can say my queue is empty. So, in that situation when we are adding the very first element, at that time we need to set both of this pointer to the 0th location. So, that is what we are doing over here, that first we are checking if front is equal to minus 1 and rear is equal to minus 1, then we are assigning the value front is equal to 0 and rear is equal to 0. That is checking for the empty queue and insert the very first element. Else, that is a normal scenario, rear is equal to rear plus 1. So, in this step 2 what we are doing, we are just setting the index value, right, for that pointer rear, right. And after doing this what we are doing, we are just storing that value at that particular position. So, that is queue of rear, right, queue, that is my array, and at the particular index, that index is already set during this, right. So, queue of rear, that is equal to value, this value can be anything, right. You can set any static value or you can take from the user and assign it to this value, right. And that is all. This is your enqueue operation. Last step is exit or return, right. So, I hope you understood this enqueue operation. Enqueue is nothing but insertion operation in a queue. Now, next we are moving ahead with the dequeue operation. Dequeue is nothing, that is deletion operation in queue, right. So, the very first step, that is checking for the underflow. Now, why we are checking for the underflow? Because if my queue is already empty, then what to delete? Right, we cannot delete anything, right. So, that is why we are checking that if front is equal to minus 1, because that is the only condition, na? Here we have checked that if my front is equal to minus 1 and rear is equal to minus 1, at that point we can say that my queue is empty, right. So, the same thing we are doing over here, that if front is equal to minus 1, then simply print queue is empty, right. And then there is no need to go further, return from here only, right. Then the second step, in the second step what we are doing, we are storing the value that we are going to delete, that particular value we are going to delete from that queue, right. So, we can use it for some processing purpose. So, for that we are storing it in some variable. You can take any variable, here I have taken var, right. Now, the next step, step 3, that we are checking that if there is only one element we are having in our queue, right. Because like usually what we do, usually like suppose we have this queue and here we have like 0, 1, 2, 3 and 4, right. So, suppose I am having 3 element, right. So, my front is pointing over here and my rear is pointing over here, and these two data are vacant, 2 positions are vacant, right. So, usually for deleting purpose what we do, front is equal to front plus 1, right. So, front is equal to front plus 1, that means this data is deleted and my front is pointing over here, right. So, still we have 2 elements, right. But what if suppose I am having this like 0, 1, 2, 3 and 4 and I am having only one data, that is 5 at the second position, that means my front is also pointing to this and my rear is also pointing to this. In this situation, if we go with our usual thing, that is front is equal to front plus 1, then my front would be incremented and it will point it to 3, but we don't have any data over there, right? So for that empty queue, what should we have? This is not correct, right? So for that, what we should have, that front should point to -1 and rear should point to -1 as well. So for that, first we are checking that if there is only one element is there in my queue, right? So for that, front is equal to rear. If front is equal to rear, then simply assign the value -1 to both of the pointer, that is front is equal to -1 and rear is equal to -1. That means my queue is again empty. If it is not like that, then simply increment your front pointer and yes, that's done, right? So the step 4, that is exit or return, right? So this is very simple dequeue algorithm. Dequeue, that means deletion operation in queue. Till now we have studied enqueue and dequeue. Enqueue, that is insertion operation in queue, and dequeue, that is deletion operation in queue. And the last one, that is display, right? Display, that means whatever is there in that queue, we want to display it, right? So for that, we are having only 2 steps are there, right? So first step, that checking for the underflow. Why there is a need for checking for the underflow? Because like if we don't have any of the data in my queue, so what to display, right? So if we still display, it will go into the infinite loop, right? So for that, we need to check whether my queue is empty or not. So we are checking that if my front is equal to -1, then simply print queue is empty and then return from here. There is no need to go further, right? Then simply we need to apply the for loop, right? That is a print every element of queue. So in that for loop, what we have, like we need to start from the front pointer and we need to go up to the rear pointer. Why? Because whatever data we have, that is in between my front and rear only. Suppose we have this like 0, 1, 2, 3, 4 and I am having data over here 5, 3 and 2. So my front is pointing to this and my rear is pointing to this, right? So whatever data, I am not having any data in the 0th position, I am not having any data in the 4th position, right? So whatever data that is in between front and rear only. So we should start with the front and we need to check I is less than or equal to rear and then we need to increment it and simply print Q of I. And that's the end of for loop, and the last one is exit or return. So this is a very simple display algorithm. So in this lecture, we have studied about the linear queue, that is a very simple queue where insertion is done at the one end, that is called as rear end, and deletion is done on the another end, that is called as front end. In the next lecture, we are going to study about another different variant of queue, that is a circular queue, double-ended queue and priority queue. Thank you.